Welcome to the Level 1 video on differentiation and integration. We're going to start off today by talking about differentiation from first principles. Okay, so a quick definition. A function, let's say f of x, is differentiable at a point x if the limit as h tends to 0 of f of x plus h minus f of x all over h exists. Okay, and this limit is called the derivative of f at x and is denoted as d dx of f of x or f dash of x. Okay, so let's look quickly at a graphical interpretation. Of what we just said. And I will do my best to illustrate this. Okay, so if these are our axes, if this is f of x and this is x, and we have some function here and we take a particular point on this function, say here, this point is x, f of x. Okay, so this is at the point x, f of x. Now, if we take a new point, x plus h, so this has distance h, that point will be here, then this point is x plus h, and f of x plus h. Okay. Okay, and the gradient here is going to be the change in y, which is f of x plus h minus f of x all over x plus h minus x. Okay, where the x's cancel, so we're left with f of x plus h minus f of x all over h. Now all we have to do is take the limit of this as h tends to 0. So as h tends to 0, this gap that we have here gets smaller and smaller and smaller until finally we have a tangent almost at this point. So the limit of f of x plus h minus f of x over h is the derivative with respect to x of f of x. So let's talk about, let's do a particular example using differentiation from first principles. Find the derivative of f of x when it equals x cubed plus 3x squared plus x plus 1. And our solution to this if we recall the formula, we're trying to find the derivative of f of x with respect to x. So we need to calculate the limit as h tends to 0 of f of x plus h minus f of x all over h. Okay, so let's go ahead and calculate what f of x plus h minus f of x all over h is. It's going to be x plus h cubed plus 3 lots of x plus h squared plus x plus h plus 1 minus f of x now, which is x cubed minus 3x squared minus x minus 1 all over h. So now we need to multiply this out, and we have x cubed plus 3h squared x plus 3hx squared plus h cubed plus 3x squared plus 6hx plus 3h squared plus x plus h plus 1 minus x cubed minus 3x squared minus x and minus 1. And we'll have some cancellation here, so the x's will cancel. We have a 3x squared will cancel. We have x cubes that cancel. We have 1's that cancel. And this is all over h. You'll notice that every term in there now contains an h, so we can divide straight through by it, and left with 3h x plus 3x squared plus h squared plus 6x plus 3h squared plus 1. And now we need to calculate the limit as h tends to 0 of f of x plus h minus f of x all over h, which is the limit as h tends to 0 of this plus h squared plus 6x plus 3h squared plus 1. So all the terms with h in it will vanish, and we'll just be left with 3x squared plus 6x plus 1. And that's the final solution. Now we can go ahead and calculate another example. So using differentiation, from first principles, find the derivative of f of x when it equals x to the n. So our solution is we need to calculate d dx of f of x using the formula as the limit of h tends to 0 of f of x plus h minus f of x all over h. And when f of x is x to the n, that's the same as x plus h to the n minus x to the n all over h. So if we multiply this out using the binomial expansion formula, we have n choose 0 x to the n plus n choose 1 x to the n minus 1 times h plus n choose 2 x to the n minus 2 times h squared plus everything in the middle plus n choose n minus 1 x to the h to the n minus 1 minus n choose n times h to the power of n minus x to the n. That's all divided by h. Then simplifying the binomial coefficients, we have x to the n plus n x to the n minus 1 h plus everything in the middle plus n x h to the n minus 1 plus h to the n minus x to the n, all still divided by h. Then we have n x to the n minus 1 h plus n choose 2 x to the n minus 2 h squared plus everything in the middle plus n x h to the n minus 1 plus h to the n, all still divided by h. Now you'll see that all the terms there contain an h, so we can divide through, so we just have n x to the n minus 1 plus n choose 2 x n minus 2 to the h plus everything in the middle x n h to the power of n minus 2 plus h to the power of n minus 1, and then taking the limit h tends to 0 of this thing means that all the terms that contain an h will disappear, so we're just left with n times x to the power of n minus 1. And that's the final solution. Thanks for listening.